Good morning, good afternoon, good evening, depending upon your time zone. Welcome to our webinar on information architecture and artificial intelligence. I coined this phrase, there's no AI without IA, back in 2016 when I wrote an article for IEEE IT Professional Magazine. And at the time, I remember talking to vendors about their chatbots and their virtual assistants. And I kept saying, well, how do you train these things? How do you change them? How do you update them? And I remember one of them at one of the conferences saying to me, showed me this interface. And the interface was showed question answer pairs. And it even showed misspellings and variations in the questions. And I'm like, wait a minute, you're not even using any kind of machine learning or classification for this. How is this maintained? How is this updated? And the answer was, well, the customer has a knowledge base. I go, really? The customer has a knowledge base. And I tell that story in the context of an old joke about making assumptions. And this joke was about economists making assumptions, right? But it applies to this. So there's a chemist, a mechanical engineer, and an economist on a desert island. And they have a container of food, but they don't have an implement to open it with. And so the chemist says, I'm going to, I'm going to erode the top with sunlight and seawater. The mechanical engineer is going to do this with coconuts and rocks. And the economist says, assume a can opener. Well, assuming you have a knowledge base is assuming you have a can opener. You cannot assume the answer to your problem, right? So basically, this is all about information architecture. And when I wrote that article, what I said was, if someone tells you you don't need taxonomies, you don't need information architecture, you don't need ontologies, you don't need any of that, that's because those decisions were already made for you. Somebody designed that into the application. And by the way, that article was posted not too long ago, and I should post it again on LinkedIn. You can do a search for it. There's no AI without IA. And again, no artificial intelligence without information architecture, because this is so critical to have that source of truth and to have that content and information structured so that your AI can retrieve it. So today I'm with Heather Eisenbraun, who's our Chief Knowledge Architect. And we are going to talk about this topic. We're going to give you some examples of from the industry. We're going to give you some very practical takeaways. And we're going to talk about why this is so critical. By the way, we have 150 registrants today, which is one of the larger numbers of registrants we've had in quite a while, which indicates how important this is for organizations and how organizations are starting to realize that the only way to do this effectively, the only way to be able to build artificial intelligence initiatives is to have your knowledge scaffolding in place, to have your knowledge architecture. And that is what's so critical. And we've also developed some tools that increase the ability to do this, the efficiency to do this by a factor of 10. I'm writing some white papers on this right now. We can talk more about that, but there are some amazing tools and approaches to being able to do this stuff, because in the past it's been very time intensive. It's been very costly. It's had required a lot of manual processes and very deep expertise that was not always easy to find. Today we're going to be recording the session. We're going to try to go under an hour, although we have 10 pounds of stuff in a 5-pound bag. We do have questions. There's a quick Q&A panel, so be sure to ask your questions there. And then we also have polls throughout the session to get a sense of who you are and what you're doing and so on. And then there's an exit poll, so be sure to take that as well. Early Information Science is not just a producer of webinars and podcasts, although our Early AI podcast is rated as one of the top 100 AI podcasts in the world. And we've had some fantastic guests. Early, it's EARLEY, and it's a podcast. You can get that wherever you get podcasts. We've had fantastic guests, people who have started and launched, billion-dollar unicorn companies. We've had people who are practitioners. We had people who are business leaders. So it's a really terrific podcast. We've been around since 1994, so we've been around the block. We've done this a few times. And what's interesting, I had another vendor who was talking to me about their solution, and what they said was, I said, well, what's the role of taxonomy, metadata, information architecture? Oh, you don't need any of that. I said, really? Well, what do you do with the data? He goes, oh, well, you have to do some data labeling. It's like, duh, data labeling, it requires metadata. Metadata requires taxonomies and ontologies, and that's all information architecture. So many times the people who are newer to this space don't necessarily have that depth of knowledge. They haven't been doing this for a long time. We've been doing this for Fortune 1000 companies for the decades that we've been around. And that's the other thing that allows us to be able to do some of the stuff we do, because we have so much depth of knowledge and expertise. And I'm going to talk about that a little bit later when we talk about our AI readiness quick check assessment, which is something you'll want to take a look at. Here we are in session 3 out of our 7-part series. If you didn't get a chance to attend the other sessions, they're recorded. You can grab those and listen to them at double speed, although I don't know if you always want to listen to me at double speed. I talk quite fast as it is, but you can give it a shot. At any rate, and then next time we're going to be talking about knowledge engineering and then content processes. We're going to get into roadmaps and then how to do an AI readiness architecture project and pilot. So today we're going to talk about why AI is so important, why IA is so important for AI. How when you look at how vector stores work, and when you look at how retrieval works, and when you look at how generative AI works, you're looking for semantic, you're looking for similarity, but you need semantic understanding. We'll talk more about what that means. And the semantic understanding is what our information architecture gives us. There are different components to information architecture. There's taxonomy, there's ontology, there's metadata. Those all improve the structure of the meaning and the structure of that content, so you can retrieve specific answers to questions. That's what we're trying to do. We're trying to get our questions answered. And in order to get exactly the right question, exactly the right answer, we need to have that structure. We'll talk about applicability and how we need to think about making sure that we're giving people exactly what they need in their context, in their jurisdiction, for their model number, for whatever their problem is, right? We need to make sure, for their role, we need to make sure we have the ability to align that content with exactly what they need. We'll talk about vocabularies and how terminology normalization is so critical to this, because if we are calling the same things by different names, or we're using a name of something that has different meanings, then we're going to have problems, and your AI is going to have problems. So we need to be able to get rid of that problem by normalizing and standardizing our terminology across different systems and processes. We'll also talk about relationships, how we need to think about the relationships of concepts, right? You have problems and you have solutions. Well, how do you align the solution with the problem? We have products and we have services. What are the services for those products? We have methodologies and we have templates. What's the right template for this methodology? We have insights and methodologies. How do I get the right insight? And so on. Those become the knowledge scaffolding of the organization. That becomes the ontology. And we'll talk more about what ontology is and how we build them. And then IA as the blueprint, right? IA is telling our knowledge and our AI how to retrieve the knowledge and how to build retrieval augmented generation tools that actually work for us. So RAG, retrieval augmented generation, is the thing that is trying to help us make sure that AI, when we're doing any type of generative AI project, retrieves the right information, right? It's saying, don't just ask the AI model what the answer is, right? Because it has a model of the world. It has an understanding of the world, but it doesn't necessarily know your particular world. It doesn't know your details. So one of the things that we need to do is we need to tell it exactly what that world is. So when we are looking at this, when we look at this, what are people doing when their retrieval augmented generation system, which again is built on a source of truth, it's built on a knowledge base, when it's giving you the wrong answer, many times people will try different prompts, or they'll try a different embedding strategy to embed the content within their vector space. Maybe they'll try a different model. And sometimes the results will improve, but it doesn't make the problem go away, right? We need to make sure that we're solving this problem at the root. And what's happening is the model is doing what it's designed to do. It's retrieving content that looks similar. What we do is we map this stuff in a vector space. What's a vector space? A vector space is basically taking your content, breaking it into pieces, and then creating a mathematical model of that has multiple dimensions. And we can only think in terms of 3 dimensions as, easily, right? Longitude, latitude, and altitude, or 3-dimensional space, X, Y, Z. We can think of a 4th dimension of time, but really these mathematical models work in n dimensions, right? There's hundreds of thousands or millions of dimensions. And what that means is it's creating this model of a piece of content in this multidimensional space. And then it's looking for stuff that's near it, right? And that's kind of how it works. And it does that's an oversimplification. But the idea is that when we're doing that, we need to, and that is a statistical or probabilistic approach, right? It's saying this is what's likely the answer to your question based on my model of that question and that answer, and based on some other probabilistic constructs and approaches. But we need something that's called deterministic. We need to make sure that we are specifically filtering for the content that we need, because many times similar is not the same as correct. It's not the same as applicable. It's not the same as safe, because close enough is not good enough, right? It really has to be precise. It really has to be exact. So without that, the AI is looking at your content without necessarily knowing what your terminology means. It doesn't necessarily know your processes, your procedures, your IP, your competitive differentiation. And when you think about how organizations compete entirely on their knowledge, right? What differentiates one company from another? We take in knowledge of customer needs, of marketplace conditions, of understanding of routes to market. We put out knowledge in terms of solutions and products. Physical products are materials and knowledge, right? I like to hold up my phone. I like to hold up my magical device, and I say, this is sand, metal, and oil, all very cleverly arranged, right? Hundreds of thousands of person years of knowledge goes into this, but that's all it is. It's materials, raw materials, and knowledge. Even money is knowledge. Money is information, right? We don't walk around with gold Krugerrands. We walk around with ones and zeros, and that information allows us to be able to apply resources to solving particular problems. So again, we need to understand how to structure that information, because this is the problem of structure and specificity around the content and around the use cases. And we're going to talk about that a little bit more. But again, the large language models understand the world. They have a model of the world. They have knowledge of the world. They don't have knowledge of your world. And you don't want it to have all the knowledge of your world, because that's proprietary stuff, right? That's how you differentiate. That's how you compete in the marketplace. Two companies can be in the exact same space, exact same products. Their processes will be very different. Their routes to market may be different. Their messaging may be different, but it's all about how they compete in that space based on that knowledge and understanding. So when you look at how AI retrieves information, it's based on similarity, right? It's based on looking at, again, those things that are in multidimensional space and saying what's different. And information architecture provides the semantics, right? It provides the structure and the meaning behind that information so you can retrieve it more specifically. Again, there's no AI without IA. IA at its fundamental construct is classification, right? Because even when we're looking at vector similarity, we're saying, does this problem, what is the nature of this problem? What is the nature of this solution? And how can I group these things together? How can I classify these things that go with one another? And again, it's simplification, but it's very, very important. Now, last time we talked about governance, and governance is so critical. It has to be foundational to everything we're doing, because we need mechanisms to make decisions, right? We need mechanisms to evaluate, to allocate resources, to determine our ROI, to monitor our technologies, to be able to determine whether something is working or not, right? To be able to harvest the best practices from across the organization, to be able to measure the results. And so governance structures are very, very important. We have a tool that helps with that. But the point here is that it tells AI what it can and can't do. What this session does, information architecture, tells it what things mean. And so these are different layers, but they're both required to be able to operate at enterprise scale. So what does the model do? Again, I've already talked about this. It matches patterns in language. It knows what words look like next to each other, and it predicts an outcome. What it doesn't do is it doesn't necessarily understand the domain meaning. It looks like it does. It sounds like it does, but it doesn't know the terminology. It doesn't know the product variations. It doesn't necessarily know that this model goes with this troubleshooting code, and this troubleshooting code requires these steps, right? And so on. And those are the things that are very nuanced. It doesn't necessarily understand the detail. These are different capabilities. They work hand in glove, and they're very, very important together. So when we look at similarity, again, if we consider a consumer approach. What's a good pasta recipe? Well, we can return 5 recipes. They can all be helpful, but nothing is dangerous there, right? It's low stakes. Close enough is fine, right? Close enough is fine. How do I replace the filter on an X2000? Or how do I switch out, this circuit breaker? Or how do I perform this maintenance procedure? That means we need to be very precise in our language, because if we're not following safety protocols, if we're not installing the correct replacement component, if we're not following the right steps to the process, something can break. Someone can get hurt, right? There's lockout procedures when we're maintaining equipment. We don't have the right lockout procedure, somebody can get hurt. And so the problem is that these things need to be extremely precise. Similarity is not close enough, right? Close enough is a liability. So that's where we need to find the similarity, but we need to find the answers, right? We need to get to those very specific answers. So when we look at how IA helps with RAG, many of these failures in retrieval augmented generation are from things like a terminology confusion. Different words mean the same thing. The same word is used to express different things. When you have revenue last quarter? Well, there's a lot of questions that can be asked about that, because revenue is an ambiguous term, right? So we need to define the context. We need to define exactly what we mean by that. We can have the right content, but the wrong context. So maybe it's the wrong product version. Maybe there's been a rev. Maybe it's a different jurisdiction, right? It applies in California, but not in Massachusetts. Or maybe it's the wrong role. You have a technical role, but you're a business person, and those types of things. And we also have a problem with fragmentation. When we start ingesting content into a large language model, into a vector space, it breaks that content up. That's just the way the process works. It componentizes it, it chunks it. And what happens is it can be chunked arbitrarily. We need to chunk things because, again, it's breaking it up and it's building this vector model, right? This mathematical model of those pieces of content. Now, when you break something up, you have to break it up in a way that makes sense. And if you break it up arbitrarily, then you're going to have fragments that may not connect together. You may have symptoms that are disconnected from their causes. You may have steps that are separated from the safety. Again, it becomes a structural problem. Let me go ahead and open up a couple of questions here while I'm here. Relationship mapping is shown as a tree or branching. Why not as a mesh? That was just a simplification, Joe. Thank you for that question. It really is not branching. It's not necessarily. There are hierarchies, but there really are meshes, right? When we think of taxonomy is usually a parent-child whole-part relationship, but then we can have a taxonomy on steroids, which is a thesaurus, which talks about non-preferred terms, preferred terms, and then things that are conceptually related. So strictly speaking, a taxonomy is hierarchy. It's isness, what is this thing? And then when we start to describe things more thoroughly, then we start getting into the things that are conceptually related. And we're going to show that a little bit later. Let's see, do we use the vector space for deduplication, and can you prevent duplication? Does it do both? That's a really good question. And I think you need to think about that prior to ingestion. That's a content curation process. So when we are doing this, and Heather, do you want to add anything to that question?
No, I think you're on the right path. Yeah.
Okay. So again, I think this is where we need to consider the curation of these pieces. Let's see, vectorization is a way to create a map. In your experience, what's the minimum viable knowledge architecture, graph, taxonomy, or ontology layer that needs to exist before vectorization becomes reliable rather than just plausible? I'm thinking specifically about what domains like industrial distribution, where wrong retrieval isn't just unhelpful, it is about safety or compliance risk. Thank you, Matthew. That's a very good question. And we're going to talk about what that means. And again, it comes back to looking at the content, understanding the scope of that content, and understanding the problem or the use case. So we don't necessarily need to solve everything when it comes to our ontology. In fact, we want to create a minimum viable product when it comes to that. But we need to make sure that it satisfies use cases. And we're going to talk more about use cases in the next session, but we'll touch on them today. Use cases tell us what good looks like. It tells us what the system will do. So if we can satisfy the use cases, that's good enough, right? But we need to be able to test those and evaluate those. So keep those questions going. Those are great questions. Thank you for those. So we talked about structural fragmentation. I'd like to start with a poll now. And I want to understand, when you guys are seeing systems return the wrong information, where do you go first? There's all these things that you need to do, but where do you go first? Do you look at the model? Do you look at the prompt? Do you look at the content? Do you look at the data pipeline? Or are you not there yet? right? So give us your thoughts on that. Where do you go when you're getting the wrong answer? And I'm seeing a tie. It's neck and neck between the prompt and the content. Now the prompt is coming up strong. Prompt is exceeding. Still the prompt, neck and neck with the content. Data pipeline is in there. People are talking about the model. This is like a little horse race, right? It's like a popcorn popping, right? It goes really fast at first, then it starts slowing down, and you start smelling the burning popcorn. Let's see, a couple more. Keep going, guys. I have a few more people who are coming in. Prompt is gaining. Do we have any more votes for content, for the model, for the data pipeline? I'm going to call it, and let's go ahead and share the results. Oops. Okay, you're seeing it now? Great. So prompt. A lot of people are starting with the prompt. Prompt is important. Prompt is a very good answer, right? There's not a wrong answer here, but the prompt has to be important because the prompt will give us context, but the content is also really critical. So looking at both makes sense. And absolutely the data pipeline, because you're processing that information before it's going in there. All of these things make sense, right? These are all areas that we need to look at. And some people haven't quite gotten there, which is fine. Okay, let's keep going. Thank you for participating. Thank you for that. Now, I want to talk about information architecture just as we would talk about architecture of a physical space, right? When we build a house, you don't start off by getting a backhoe or an excavator. You start just digging holes and pouring foundations, right? What do we start with? We start with a plan. We start with an architecture. And just like with a physical architecture, there are multiple plans. It's not a single thing, right? We need a foundation plan. We need a framing plan. We need an HVAC plan. We need a plumbing plan. We need an electrical plan. We need renderings, right? We need finish plans. We need all of these different things that tell us how to build that house. Same thing with your information house. Your information house has lots of different plans. So your architecture for that information house consists of these elements: vocabulary, taxonomy, ontology, metadata structures, content models, search integration, the user experience, the wireframes, the workflow processes, supporting processes. These are all part of your information architecture. Let me grab another quick question here, but to use temporal data retention. So you'd have to say more, but the idea is taking a snapshot of data in time, right? That would be temporal. And I think that's an important consideration because it is important to understand what does your data look like at any point in time so you can measure things, right? Because again, what you're doing is you want to have an improvement. You have a problem, you need to have some type of intervention when you have that problem. And then you need to measure. So you're measuring, you're looking at something that's out of range, you're remediating, and then you're measuring again. Yes, it's important to have a snapshot in time of that data because that's going to lead to other types of decisions. So the temporal way of looking at that, and correct me if I'm wrong in terms of interpreting your question, having that snapshot in time is very important in these initiatives. So there's lots of different ways to look at that. So tell me if I got that right or if you need more information on that. When we look at information architecture, again, we talked about these components. The vocabulary is sort of the atomic level, right? What are the terms? What are the concepts? And one of the things I want to get across here is that a concept doesn't start at the data level, right? It doesn't start at the level of getting into a specific application. It's like master data projects, right? Master data projects say, what is the name of the data field and what is the value? Okay, now we are not talking about that because that misses a lot of context. Let me give you an example. If you take the example of SharePoint, right? SharePoint has lots of different structures. It has site collections and sites and libraries and lists and content types and field metadata fields and vocabularies and so on, and taxonomy management. But let's imagine we have a concept. And this is why we start at the business concept level. We have a concept that's called methodology. Very important for a consulting firm, professional services. We could have a site collection of methodology. All these different sites talk about different types of methodologies. We could have a site called methodology. We could have a library within a site called methodology. We could have a list within a library called methodology. We could have a content type called methodology. We could have a metadata field within that content type called methodology, or we could have a term in a vocabulary called methodology. If we start at the data level, we are missing all of that context, right? Because when we build out our terminology, when we build out our ontology, those are conceptual relationships. Those are business concepts. That's what's important to the organization. We then have to build it into multiple systems and processes and applications in order and workflows in order to realize the benefit and the value. So that's why sometimes some people say, oh, we're just going to add a term to the taxonomy. It's not that simple, right? Because you're looking at a lot of different things. So we're going to talk about these different elements. Again, vocabulary is the atomic level of the term, the concept. Taxonomy is a hierarchy, whole, part, parent, child. You do have things called navigational hierarchies or navigational taxonomies. That's where you're kind of looking through and going to a website and looking at the categories of products. But we also have classification. Navigation is static, classification is dynamic. And again, that gets into how we apply metadata. Ontology is really the collection of all the taxonomies and their relationships between them. And we're going to show you examples of that. But that becomes the knowledge scaffolding of the enterprise. And then when we start considering metadata, metadata is really the isness and aboutness of content or data. What is this thing? This is a contract. Well, if I have 1,000 contracts in a pile, how do I tell them apart? Well, there are employment contracts and purchase and sale contracts and project contracts and so on. There's lots of it. That's the aboutness, right? What is it and what can you tell me about it? The aboutness is metadata. Isness is metadata. But again, we're expressing our organizing principles from taxonomy as these principles, as isness and aboutness. Let me grab this. In terms of concepts, which are really abstractions, can you deconstruct the abstraction to be used to integrate with the other abstraction? Now, that is an abstract question. That's an abstraction of abstractions. I think what it comes down to is, again, it comes back to the use case, right? Because you have to make use cases tangible. They have to be measurable. They have to be unambiguous. The user does this and the system does this, right? I am a salesperson. I need to find prospects. I am a marketing person. I need to create a campaign. I need to retrieve the right policy for this insurance customer, right? Those are very specific things that can be measured. You can succeed or you can fail. And we want to be able to measure baselines. So when we get into concepts and terminology, it's really, they become the handles on content, right? You reach into this ocean of information, this ocean of content and documents and data in your organization. And you say, what handle can I grab onto to pull this information back? That's what the concepts do for us. That's what the terminology does for us. That's what the metadata does for us. So if I can satisfy my use case, then I have the ability to do this. So here's another question, Matthew. In complex B2B environments, AI doesn't just need a map of products. It needs to understand the customer's context, the contract pricing, approval workflows, past purchase problems, equipment install base. That's not one knowledge graph. It's several plus transactional systems plus ERP. How do you think about the IA challenge when the semantic foundation has to span multiple systems and different data models? That is a great, great question. And what I'll say is it doesn't necessarily, some people think in terms of multiple knowledge graphs. And again, just to get people up to speed on the terminology, ontology is the structure. Knowledge graph is the structure on the data, right? And all the things that Matthew just talked about can be part of that knowledge graph. They can reside in different systems. The ontology overlays all of that. And you can have multiple knowledge graphs, but it's best to kind of think of this as a holistic system with different branches that serve different purposes, right? But again, you're trying to organize and rationalize all of those systems and processes, past customer purchases, as-built configurations, right? That's one of the things we had to do for applied materials. There's a Harvard Business Review case study on that. So it was a great project, saved them $50 million per year by organizing field service knowledge. But the point here is that as built was very important, right? What does the customer have in their environment? What purchases have they made? What's their history of service tickets? All of those are what we call digital body language, right? What are the things and the signals that we can retrieve and capture and gather and harmonize from different systems and processes? All of those things go into influencing the answer. And again, all of those things need to be organized and managed in terms of our data processes, our content processes. Heather, I'm going to turn this over to you to talk a little bit about vocabulary normalization. It's about time for me to stop talking. I've been rambling on for quite a while here.
Yeah, so you set up the problem great, and I'm going to take them through each of the four components of IA that solve this problem. So if y'all want to assess how AI ready your IA is, you could treat each of these four components as a diagnostic. And as I walk through them, you can ask yourself, do we have this? Is it missing? Could that gap explain where our AI retrieval is breaking down? And we're going to start with vocabulary. So on the left side of this diagram, you have three terms: deviation, nonconformance, and exception. And in many organizations, they're used interchangeably. Different teams, different systems, different documentations, all using different words for what is essentially the same concept. But here's the thing: AI doesn't know that these are all the same thing unless you tell it. It will treat each one as a separate concept and return different results depending on which word the user happens to type. That's a terminology problem. What vocabulary normalization does is say we pick a preferred term, in this case deviation, and now when someone searches for nonconformance or exception, the system knows to retrieve content tagged with the preferred term. So it's one concept, one term, and consistent retrieval. So while this sounds simple in practice, it requires getting subject matter experts in a room and agreeing on what things should actually be called. That conversation is almost always harder than what people expect it to be. And it goes back to what Seth was saying about naming the concept that's important to the business.
And I'll tell you, doing that kind of work, more organizations have told me that that was incredibly valuable, just doing that, because it got people on the same page and it got them understanding how their perspectives differed, right? They were like, wow, I never knew you. And it also creates awareness of the problems, right? So doing this kind of exercise can be done fairly quickly, but it really brings people together and understands those different perspectives.
So once you have a consistent vocabulary, the next question is, how do you organize it? And that's what taxonomy does. It's a classification structure. It defines what belongs together, what must stay separate, and why. You can think of it as an organized map of your domain. So what taxonomy tells AI is essentially, here are the categories, here are the labels for those categories, and here's where each piece of content belongs within that structure. And that's what makes retrieval paths narrow and precise rather than wide and approximate. So without taxonomy, AI has no reliable way to tell related content apart. And that's the key risk here, that's when retrieval errors happen, when you get a wrong version or a wrong procedure or the wrong answer. The taxonomy is what keeps those boundaries clear. So here's a real example of what a taxonomy looks like in practice. This is for regulatory compliance, and specifically, these are the facets rather than the parent-child view of it.
Well,
So
you can think of a parent as the facet name for regulatory entity, and the children are those entities, right? Or those entries. And one of the things to observe here is there's no one grand galactic uber taxonomy, multiple taxonomies. Carry on.
Yep. So each of these boxes is a vocabulary, which is a set of controlled terms that describe one domain dimension of the compliance world. And the important thing to notice is how many dimensions there are, right? There are 15 here, 15 distinct facets. That's what it takes to describe accurately a compliance document in a way that AI can retrieve it, right? So when you have this in place, you can say, hey, give me documents that are about anti-money laundering under EU jurisdiction with an active risk status for a compliance controls review. Without it, you're asking AI to figure out what AML in Europe means, and it's just guessing. So a taxonomy tells AI what things are called and how they're organized, but it doesn't tell AI how the concepts relate to each other. And that's where ontology comes in. So what you're seeing here is an ontology for that same compliance domain. And you can see the entities here: regulatory entity, organization role, jurisdiction, and so forth. And more importantly, you can see the relationships between them. Those labeled connections are the key. Each one carries the meaning that AI can act on. So let me give you two concrete examples of why this matters. Say a user asks, what are my responsibilities as an auditor at Vanguard? Without this relationship between role and organization, AI could return everything about auditor responsibilities, generic or untargeted. But with that relationship, it knows to filter what applies to that role within the specific organization, and the answer is scoped appropriately. Or take this one. Go ahead, Seth.
Keep going. Go ahead.
Okay. What testing procedures are required before submitting our Form 10K? Without the associative relationship between tasks and document types, AI has no way to connect controls to that specific filing. So it might return all testing procedures or none that are relevant. With that relationship explicitly mapped, it surfaces exactly what applies.
And by the way, the terminology here are the types of relationships. So hierarchical, that's the parent-child whole part relationship of the traditional taxonomy. So you can see jurisdiction is part of a regulatory entity. There's a jurisdiction, a regulatory regulator and regulatory entity are synonyms. So that's called an entry term or equivalent term. And then associative are things that are conceptually related. So whatever conceptual relationship you can come up with, you can have, right? So it's really limitless. And this is where you really get the nuance of the maps of the enterprise knowledge, the organizational knowledge. You get that by understanding these associative relationships. How do these concepts relate? That usually takes subject matter expertise, that takes experience, that takes knowledge. It's the reference librarian who says, "Oh, you're looking for information on the American Revolution. Well, you really should read this biography of John Adams, right?" You might not know that by looking that up, and so the reference librarian tells you to see. It's the back of the book, see also, but it's why do you want to see it? You see it because, again, it's a responsibility for that role. It's a process for that responsibility. It's a regulation for that process, and so on. So those are associated relationships. I have a couple of questions. Who should own the map in an enterprise? In my experience, this is Matthew. Thank you, Matthew. Teams closest to domain knowledge, product data, merchandising, engineering are rarely the teams driving AI strategy. Do you see that gap closing? How might these teams help to close the gap? That is a really good question, because what happens now is that we have situations where people do not have a seat at the table. We need to have a seat at the table. The right people have to be in the room. People that understand content, people that understand componentization, people that understand the products, the services, the solutions. We have to create a cross-disciplinary team, a multidisciplinary team, a cross-department, cross-organization. And that's part of governance. And governance, and what you'll see if you listen to the prior episode, session on AI governance, what you'll see is there are different structures to different types of entities. So you have a committee, which is kind of the strategic level. We have working groups that are hammering out problems. And then you have task forces, which are really the people that are limited duration solving, they're a SWAT team. They're solving a particular problem. What we need to have at that working group level and working group is ongoing, right? And a task force is limited duration, committee is ongoing. We need to have the right level of collaboration, and we also have to have the right change management processes, because you might have minor changes and you have major changes to things like taxonomies and ontologies and terminology. Minor change, easy enough to implement. Major change might be a new facet, a new vocabulary, a new relationship, a new product, and so on. So the idea is that you do need those people who are close to the products. They're the subject matter experts. They need to have input on these things, and the right governance structure will give you that input process, and the right change management workflow, because workflows are very important. So those are great questions. And yes, I totally agree that those people need to be there. For some companies sitting on large but messy product data sets, tens of millions of SKUs, inconsistent attributes, mixed taxonomies from acquisitions, where do you see the highest ROI entry point? Vectorize what you have and iterate, invest in cleaning first, or something else entirely? Again, that's a really great question, because that is the reality. That is the reality of what you see in these organizations. And it really does depend on the use case, and it depends on the current state. Because you can go in, you can do things like, let's normalize our brands and improve that in search. Let's start normalizing attributes, right? Let's start doing product data fill. The first thing to think about is the hierarchical taxonomy that is the navigational structure, right? How are products organized? Are they organized in a way that aligns with the mental model of the user, right? Because that's what's going to give you a good experience. When you go into a site, you go, wow, this site is great. They have all these great products, and I can find what they need, and they make good recommendations. That's because that site is organized in a way that you think, right? It's aligned with your mental model. And different people have different mental models. So we have to test across roles, and we have to understand what that role is. So building out that navigational hierarchy is critically important. It tells you intuitively what things belong where. You might be looking for a particular type of doctor. You might look for a term that's not in the hierarchy, but you'll look under doctors, right? Like in other words, you know that it's a type of a doctor, so you'll look under doctors, right? For a very unique type of a specialty. So the point here is that you want to know where to look under certain categories. Polyhierarchy, meaning putting things in multiple places to make it easier to find, actually breaks the mental model. It's an interesting concept. So being able to normalize that hierarchy, that navigational structure, is a great place to start. but then also looking at the quality of those other attributes and those data sources will help you with that. So that's so the answer is, and you can see what happens if you do vectorize things, right? You can see how well it'll work, but there's an iterative approach to doing that. But there are some there's low hanging fruit. And many times what you're doing is you're doing the enrichment at the search level, the search index level. I don't want to go into too much detail. What's the role of a data dictionary? Data dictionary is a source of where you are agreeing upon terminology and metadata fields, right? The data fields. A data dictionary is a great place to start when you're talking about understanding vocabularies, because they have the official structure that the organization uses. And if something is not in the data dictionary, then you need to think about how it fits in with the data dictionary. But the data dictionary becomes an input to building all of these structures. Thank you for those questions. Those are great questions. Go ahead, Heather, you want to talk more about ontology?
Yeah, let me just bring us back onto the path and just summarize that last one as, AI. So the ontology is giving us the ability to reason across the concepts, right? Not just retrieve within a category, but follow the connections. And that means that AI can surface that full chain of meaning that the user actually needs. So just wanted to put that in context before we move on to another one, which is showing in practice the real power here is what happens when those relationships change. We chain them together, right? So this is a troubleshooting chain. And when a symptom appears, it points to a set of potential causes, and then those causes are confirmed by diagnostic tests. The diagnostic tests determine a corrective action. The corrective action is verified by a test procedure, and so forth. That entire sequence is what someone needs when they're troubleshooting a problem, not just the symptom, not just the corrective action. They need the whole chain in that order. And without an ontology, AI can surface just isolated. It might return the corrective action without the diagnostic test. It might surface the symptom without the cause. It might return steps that are out of order. But with the ontology, AI can follow the connections and return the full chain of meaning the way the user actually needs to use it. And if you go forward in the animation real quick, I just want to point out that there are different types of relationships here. You have procedural sequences, you have cause and effect, you have dependency chains. So there's lots of other kinds of relationship types in addition to the equivalents and the other ones we talked about earlier.
Yeah, those are generic equivalents. You can have certain types of equivalence terms. So you could say abbreviations or code name or layperson terms versus technical terms, right? Those are all equivalents, but there's specific types of equivalents. So you can get into that level of granularity. And then the associative relationships are the things that Heather is talking about, lots of different ways of associating these concepts. Oh, okay. So this is the convergence and the, go ahead, let's talk through this. How do you derive these things? How do you create them? They usually take a lot of work, but there's ways of accelerating that. Go ahead, Heather.
Yeah, so this is how we actually build ontologies in practice, because it's not a purely manual exercise anymore. And I think we should keep this one really brief because we're running very short on time. But we use a convergent approach, which is top down and bottom up simultaneously. So the top down means we're starting with a seed ontology, and the bottom up means we're using AI agents to extract entities and relationships from existing content. And when those two approaches work together, we eventually hit a convergence where we're not finding new entities and relationships. So it's much, much faster to develop these now than it used to be. And we're going to go into more detail on this in the next session on knowledge engineering.
Yeah, that's great. And again, the point here is that the old way of doing this is manual. The new way of doing this is augmented, and there are ways to accelerate that very, very significantly. So over time, you get increasing levels of automation.
Yeah, so the fourth component is metadata. Seth already talked about this, the isness and the aboutness, and together those terms make it something that AI can do something with this, right? So if we look at it on the right, we have the isness, it's a procedure, and it's version 7.3, and the status is approved. That's what it is, right? That's what that piece of content is. But it's about this X2000 model for the European market. And if you look at the left, without the metadata, you have two procedures, very similarly named. They have nearly identical file names, nearly identical content, and AI retrieves both based on similarity. The technician could very easily get the wrong version, but with a high confidence rating. With the metadata, AI can retrieve exactly one result, and it's the right one. So this is the difference between AI that retrieves by similarity and AI that retrieves by meaning. So these four components don't operate independently. Think about it this way. If vocabulary is a dictionary, taxonomy is the filing system, ontology is the map, how everything connects, and metadata is the label on each document, It tells you exactly what it is and when it applies. Okay, applicability. We kind of touched on this, but basically AI can return the right procedure to you, but it might be the wrong product version, right? Not the one you were asking, or the right rule for the wrong jurisdiction, or the right step for the wrong role. And it's really hard for you, the user, or AI to detect those patterns. And so what we want is to apply this logic, and what it does is it uses the metadata as filters, right? So take this query, how do I replace the filter? And without any filter, you get quite a large set of results, right? And as you apply each filter, it reduces it until in the end you end up with one answer, the right answer, right? And that's what's meant by that logic. It has to be built into the AI from the start, and the decision about which dimensions matter and how to encode them have to be made before the content is ingested, before retrieval is configured, before the system goes live. And that's part of the use case development, is how do people need to access these things? Like, what are the handles that Seth talked about that you need to pull, or the levers you need to pull to find that? And that's those are the four components of the IA work that has to happen before the system goes live.
So one of the questions was, is this master data management? And why don't we do this poll while I'm answering that question? So do you have explicit metadata that you apply to your content consistently in some areas, minimally, or not sure? So let us know if you are using metadata. Now, one of the questions is, how does this relate to master data? And again, master data is giving you a source of truth around data. And it is part of this. It is part of the IA. It is part of the metadata. It is part of the control vocabularies. What it doesn't give you is it doesn't give you all those ontological relationships, but that's okay. Master data does fill a role. It is the defined gold standard for data. And so right now we're seeing kind of a broad swath of answers. Some people are doing it consistently. That's great. In some areas, minimally, not at all, we're not sure. So it has to be done consistently, right? And this is where you can build things that will do this. Use auto classification. You can use AI to do this, but the idea is that we need to be able to have a reference model to tell the AI what those entities are and how they need to be classified. Okay, let's carry on. Now, I guess, well, we're really kind of at the end here. I'm going to talk about a couple of other things, but the next session is going to be on knowledge engineering, which is how we build these things, right? How we take documents and procedures and expert knowledge and how it has to be transformed. It's not trivial, right? It does require a good bit of work. So do we want to do this? I guess we could do this really quickly. How does your organization stand when it comes to structuring knowledge for AI? Do you not have a formal IA? IA exists for search, but not AI. The IA is built with retrieval. IA is established and active for AI, or none of the above. So just give us a couple more answers to this, and then we'll be wrapping up shortly so that you can get on with your day. So a lot of folks are saying they have no formal IA. That is really a big gap, right? That is something that you need to think about. I'll give you another minute. I'm still seeing IA exists, but not for search, but not for AI. Okay, that's good. You have it. But now you need to apply it. And then we see IAs being built with AI retrieval in mind. That's really good. Okay. But we don't necessarily see a lot of companies that have it actively used for AI. So let me give it one more second. Okay. Now we'll share the results. And there you go. So some are none of the above. IA is established in just a little bit, but a lot of folks don't have any formal IA and some are building it. Okay, great. So let's wrap up shortly. What I want to do is tell you about the AI readiness quick check. This is incredibly valuable. This is something we are going to be charging for. Right now, we are not charging money for it but it is, excuse me. But this is something you're going to want to do because people commented that this is incredibly valuable. Why are we giving this away for free? We're beta testing it. We're almost done with the beta test, but I will, if you guys take this, I will give you the report. We are very careful about data and data confidentiality. There's a certificate that talks about the fact that we do not share your data. We can also do an NDA if you want, but take this readiness. This comes up to be a 15 or 20 page report that is very specific to your organization, to your industry. It really is incredibly comprehensive, and it's built on hundreds and hundreds of pages of our IP. Of course, we use a large language model to build the report, but it's based on the survey and it's based on the methodologies and the case studies and the background that we do. And we also do additional research. But again, this is going to be priced at $2,500 for the first survey, $1,000 for every additional survey after that. If you take it now, try to get it, try to take it for, or have other people in your organization take it as well, because getting that comprehensive picture is very valuable. I'll answer another quick question here. Process of normalizing vocabulary in an organization is much a negotiation process as conceptualization. Yes, it is negotiation. It absolutely requires that. Where's the market on this? Is there a system to implement that integrates these concepts into the AI lever? Is this Palantir, or is this a patchwork of software to do this? We actually have tools that do this. There are tools out there, but we can set up a call to talk about some of our accelerators. We have a bunch of tools that we've built over the years that take these concepts and allow you to accelerate, just like I showed you with ontology development. And then there is a larger framework that we use for organizations. This is an actual project. It might be a 4 or 6 week project, but this cuts across 74 questions. 17 factors, but start with the quick check. The quick check will give you a nice picture of what is going on in the organization. But then again, this gives you a more detailed roadmap. And I did have a table that compares these. I'll share that on the website. But the idea is the quick check really identifies what those issues are and then gives you recommendations. And then the full AI readiness 74 question framework gives you a lot of diagnostic and a lot of details and builds a plan of attack. So take a look at that. And with that, our next session is going to be on April 22nd, and that is going to be at 1 p.m. We're going to talk about knowledge engineering. So information architecture is that blueprint, as we say. Knowledge engineering builds that application. So that's what we're going to talk about. And so the documents and the procedures and all those pieces need to be brought together. Give me a call, send me a note. Happy to have a conversation. Take the readiness quick check. And then also, if you're interested in sharing your experience, I'm going to be an editor of a special topic issue of the Journal of Applied Marketing Analytics on AI governance. So send me a note to discuss that. Send a note to Seth at Earley.com. With that, I will let you guys go. Thanks, everyone. Thanks, Heather.